Hello, everyone. Good morning, good afternoon, and good evening, depending on your time zone. As mentioned by Francesca, I'm a staff scientist in the TB Supranational Reference Laboratory in Milan and core group member of the Global Laboratory Initiative. Before going into the topic, let me introduce very briefly the activities of the GLI. GLI is one of the 7 working groups of the Stop TB Partnership and represents stakeholders and institutions that are involved in the laboratory strengthening. So the mission of the GLI is to serve as a collaborative platform for the development and uptake of practical guidance and tools for building high-quality TB diagnostic networks. So across the activities, there is the implementation of policy guidance on laboratory strengthening, health system solutions and innovation for ensuring rapid uptake to the new test and appropriate patient management, continuous quality improvement, integration of diagnostic networks, and HR capacity building. There is a QR code here that will link you directly to the page of the GLI. So the topic of today is the recent recommendation for the use of tNGS for drug-resistant TB detection that came from WHO last week. What is the diagnostic gap behind? So we know that the number of people with MDR-TB who are put on proper diagnosis and treatment is unacceptably low. On the other side, we now have MDR regimens that have been demonstrated to be effective to ensure an improvement in the quality of life of people living with TB. However, these regimens are not accompanied by appropriate drug-resistant testing, and specifically, the WHO recommended rapid diagnostics existing that are currently recommended by the WHO cannot detect resistance to all the drugs that are included in these types of regimens. That's why next-generation sequencing emerged as a comprehensive approach, a promising approach for drug-resistant TB detection. And in this regard, it provides comprehensive resistance prediction that can match the modern treatment regimens. And yes, it is being used for the surveillance of drug-resistant tuberculosis in high-burden settings, and it can be used for outbreak investigation and for running phylogenetic studies and other research work, and Tim will talk about it likely. For the guideline process of the recent WHO guidance, the class of targeted NGS products was defined as technologies that use massively parallel sequences to detect resistance to the TB drugs, starting from a DNA extracted from a patient sample and ending with an automated report of results using the WHO standard catalog of mutations. 3 products met the inclusion criteria for the evaluations: the Diplex from GenoScreen, Ampor TB from Oxford Nanopore, and the TB-Sec from Shenting. The drugs that were reviewed in this guideline process were all the first-line, second-line drugs, and including also bedaquiline, linezolid, and clofazimine. And the WHO convened a GDG accordingly last year, more or less 1 year ago. And this is the link to the complete publications, if you are interested. So what are the key findings from this work? tNGS was found to be accurate among people with bacteriologically confirmed pulmonary TB. Here you can see there is the pool sensitivity that is more than 95% for the first-line drugs, moxifloxacin, levofloxacin, and 88% for pyrazinamide. Specificity was extremely high for all the drugs. There is a percentage of indeterminate results that depends on specific drugs. But what I want to mention is that the higher indeterminate rates was found in samples with lower bacterial load, and we will discuss this later on. And here you also see the test performance among people with rifampicin-resistant tuberculosis. And the tNGS was found to be accurate for isoniazid, levofloxacin, moxifloxacin, pyrazinamide, and ethambutol. and acceptable for the other drugs, including bedaquiline, 68%, linezolid, clofazimine, amikacin, and pyrazinamide. And the specificity, again, was very high for all the drugs except streptomycin. So, according to this evidence, the WHO recommends the use of tNGS tests as a follow-on test to detect drug resistance in these situations. People with bacteriologically confirmed pulmonary TB, tNGS can be used to detect resistance to rifampicin, isoniazid, fluoroquinolone, pyrazinamide, and ethambutol rather than phenotypic DST. And in people with bacteriologically confirmed RIF-resistant pulmonary TB disease, tNGS may be used to detect resistance to isoniazid, fluoroquinolones, bedaquiline, linezolid, clofazimine, pyrazinamide, ethambutol, amikacin, and streptomycin rather than phenotypic DST. And below here in the slides, you see the specific drugs that are recommended for the three products, and you can appreciate it. For example, bedaquiline and clofazimine is recommended for use on the duplex MIC-TB from GenoScreen currently. This is the algorithms that for using tNGS as follow-on test. So everything starts with a person who is diagnosed with MDR-RRTB using the entry test. Then an additional 1 or 2 samples are collected for tNGS-based DST and for the conventional phenotypic DST according to the national guidelines. And once we have the results for bedaquiline, fluoroquinolone, linezolid, and the other drugs, the treatment regimen can be reviewed accordingly and modified. And then additional DST is conducted in accordance with national guidelines in order to revise and correct the regimens based on the results of this additional DST. Now I want to share you some notes to the implementation of tNGS that I consider relevant and can also drive the discussions later. tNGS is suitable for use at the central laboratory or national reference laboratory levels because it has been shown to be feasible under routine conditions, although some complexity related to the laboratory activities has been underlined. This class of test does not replace the WHO recommended rapid tests that are more accessible, cheaper, and easier for detecting resistance to rifampicin, isoniazid, and fluoroquinolones. However, this class can be considered an alternative for prioritized groups requiring comprehensive DST with faster turnaround times compared to the phenotypic testing. Phenotypic DST is still recommended for those drugs for which there are no rapid molecular DST methods or where their performance is suboptimal. Specifically, in the case of isoniazid resistance without rifampicin resistance, tNGS can be used for prioritized groups that includes prior exposure, high resistance probabilities, and contacts of people with isoniazid resistant TB. Priority for tNGS testing should be given to those samples with higher bacillary load, which is defined as a high or medium scored at expert testing, or to positivity range if microscopy investigation is done. This doesn't mean that tNGS cannot be used on samples with lower bacillary load, but you would have to acknowledge some indeterminate results. Then the WHO stresses the importance of the multi-disease approach when using the next generation sequencing platforms, given the important capital investment that is usually associated to these platforms, provided that the proper and regular routine testing is not affected by using the platform for multiple purposes. If the tNGS and phenotypic DST is performed in the same laboratory, collecting one additional specimen after the one used for the entry test may be sufficient. And if the results of tNGS is indeterminate, the test can be repeated, provided that we have available fresh samples where the bacterial load is expected to be higher than the previous one. Then for taking clinical decision, it is stressed in the WHO guideline to consider the pretest probability of resistance. And I think we will go back to this together with the team and Christoph later. Now, moving to the implementation aspects for tNGS, we do have available already an implementation manual from the WHO and FIND that outlines what are the critical steps and the key components in the implementation process of NGS for drug-resistant TB surveillance and now also for routine use. And these guidance documents includes those aspects that are important for country planning, for example, the establishment of technical working groups, the definition of the intended use, the incorporation of NGS into the algorithms, the budgeting, the regulatory aspects, the procurement of equipment and reagents, the supply chains, HR capacity building, the development of standard operating procedures for the tNGS workflow, how to record, how to report, and how to transfer the tNGS results into existing databases, QA and QC, of course, monitoring and evaluation. All these are addressed in the implementation manual that is reported here. Last slide I have is on the document that has been very recently, today, I would say, published by the GLI. So following the publication of the new recommendation by WHO on the use of tNGS, the GLI published frequently asked questions document on genomic sequencing. The documents can be accessed through the use of this QR code, and I also reported the link to the web page. So these documents provide answers to common questions that are raised by the laboratories and by the programs that are aiming to introduce tNGS into the TB diagnostic workflow, and includes chapters with questions on general issues, laboratory components, downstreams bioinformatics analysis. It currently includes answers to 35 questions. And here I just showing you some example of questions and answers from the document. And you can see that you can also access relevant reference and links in the documents that will redirect you to the relevant documents on this topic. Another important consideration for this document is that it's a living document, so it is expected to be updated regularly according to the questions and the needs that are raised by the laboratories and the programs that are approaching tNGS. So this is my last slides for now, and I look forward to further discussions after the other two talks. Thank you very much, and I will stop sharing now.